Assalamualaikum and hi everyone. My name is Nur Sakira binti Adnan. Here I want to show to you the result of my final year project. First of all, let me introduce my project which entitled 3D printed 3.5 GHz quad-rich horn antenna for mid-band 5G application. Horn antenna are a form of broadband antenna with several benefits. A horn antenna is an antenna that are easily improved by modifying the construction characteristic. This antenna does have a better directivity, higher antenna gains, low VSWR, broader bandwidth, and also have a smaller weight. So, in order to achieve the purpose of this project, a simple horn antenna needs to be improved. Since horn antenna is very popular at ultra-high frequency, so in order to achieve the purpose of this project, which we have to get 3.5 GHz, so we need to use the reject for our project. This reject is used to obtain a narrow band for our antenna. Because the quad-rich horn antenna has made of 4 rejects with a specified distance, so it required a fabrication technique with specified dimension. So the use of 3D printing technology, particularly based on PLA, has showed promise in the fabrication of quad-reject horn antenna. It has the ability to set up the antenna with high precision, small weight, and also a short time of range. For main purpose of this project is to design a 3.5 GHz quad-rich horn antenna for mid-band 5G application using CST software. Also, to fabricate a 3.5 GHz quad-rich horn antenna for mid-band 5G application using PLA in 3D printing technique. And next is to analyze and verify quad-rich horn antenna.
As you can see here, this is the design of quad-rich horn antenna using CST software. Okay, this is the component that I used to design this antenna. It includes aperture, bell, and so on. These are the view of the antenna. As this antenna is quad-reject, so it's require 4 reject on each side. This is the far field result of the antenna. Right? This is the result in 3D plot, 2D plot, and also polar plot. As for the S11 parameter, for this antenna, I get the resonance frequency at 3.52 GHz at -30.43 dB. Oh yeah, for your information, this is the parameter list which I used to design this antenna. I can just change the parameter of the antenna at this parameter list. For the S11 result, I try to do an analysis which if I change the value of reach height and reach width, it will affect the resonant frequency or not. And here is the result. From all of this value, I can know that which one is my perfect result of my antenna, which is at line 52, 8.41667 mm of reject height. from the result of this resonance frequency, so I chose 8.41667 mm of reject height. So I use the same value of reject height, but the different value of reject width. So we can see the difference of the change of the resonance frequency in the simulation. So from the result, we can see that the less value of reject width, then the value of dB also increase. Here I attach some close-up result of the analysis. Okay, next I show you the difference when the value of reject width is remain the same, but the reject height is changed. So we can observe the signal of the frequency. Okay, let's see the close-up result of the analysis. From here, we can see that the resonance frequency goes to the left and the value of dB is also decreased.